This is totally easy once you understand the physics. Watch this, left, yep, right, go back to the right. Easy, you'll see a flip. 1, 2, 3. Yeah! Awesome!
So, as a kid, I spent many an hour in a book about the drawings of Leonardo da Vinci. In particular, his flying machines. Check out this medieval helicopter. It looks like it would work, but you can't really judge a book by its cover because there's no way to provide counter torque to the body of the aircraft. Modern day helicopters do this by providing a counter torque rotor on a boom, a tail rotor. This works by stopping the rotation of the helicopter, but here's what you haven't thought about. You are, after all, applying a force to a free-floating body, which means that body wants to drift. So how does a helicopter keep from drifting? We're going to take a journey. We're going to go from a top-level knowledge of how helicopters work to a really deep understanding. How you doing, Mr. Ledbetter?
I'm Richard Ledbetter. I'm a docent at the National Air and Space Museum.
All right. So what do you have to show us today about how helicopters work?
Well, I guess what we're going to talk about is kind of the main rotor system on a conventional helicopter, and the main rotor system basically provides both the lift and the control for the helicopter. And how we control the helicopter is by varying the pitch at each of the rotor blades.
So how do you vary the pitch on a helicopter when it's rotating, when the blades are rotating?
We use, on most helicopters, we use something called a swash plate.
Okay.
And essentially what a swash plate does is it converts non-rotating to rotating control motion. We have two kinds of control for the helicopter, and for cyclic inputs, what happens is that swash plate will just simply rotate forward or rotate aft, and that changes the input to each of the rotor blades. But for collective pitch, what will happen is that swash plate will actually move up or down. That will actually change the pitch in both of those rotor blades at exactly the same time.
Oh, okay, I just learned something. So in summary, there's three types of control. There's collective pitch, there is cyclic pitch, and then there's anti-torque. Of course, anti-torque is the rotor system on the back. So let's start with collective, Carl. So what is this magical device right here?
This is the swash plate, and this is the source of all control for any helicopter. Any direction the swash plate moves, for the most part, the helicopter follows. So if the collective is where you change the pitch of both blades, either up or down, and that pulls the helicopter up or down. You do not control the altitude of the helicopter by the speed of the blades. That stays the same.
It's translated up or down, and that controls how much of a bite of air the rotors take. Is that correct?
That is, absolutely. And that'll actually make the helicopter either go up or down. Or if it's upside down, it's backwards.
Oh yeah, because it's upside down, because I'm a helicopter genius.
The tail rotor, just like the main blades, never changes speed. So in order to control the thrust, we change the pitch on the blades so it can push or pull in both directions.
And the reason it does that, it's basically a reaction torque to what's going on up here. The blades are putting a torque into the body, is that correct?
Yep, the act of spinning the blades makes the helicopter want to go the opposite direction.
Makes sense. Can you show me what cyclic pitch looks like now?
Cyclic pitch is where the swash plate tilts and through the linkage controls the pitch of the blades and changes it every revolution to control the pitch and roll of the helicopter.
Give me cyclic pitch in this direction. Okay, but then if I rotate it, it'll change as it goes around, correct?
It does change.
So that linkage rides on the swash plate and then pushes up on the side of the blade, and then that in turn changes the blade depending on where it is in the rotation of the rotor shaft, right?
Correct.
All right. And so what does that do for you?
That lets me flip it any way I want to.
That lets me do wizardry. Okay, now you speak helicopter. And for the next few videos, prepare for your mind to be blown, but we're going to be using these fundamental terms. So get ready. Go ahead and subscribe so you can see this video series. It's worth it.